This function right here, this quadratic, it's a parabola. You know parabolas, we know what they look like. They look like that. Now, here's what we're told, that this function is positive. That means it lies above the graph lies above the x-axis from 0 to 3, and then out again from 7 to 10. But between 3 and 7, this graph is negative. Now, we don't have to do this because we're told the information we need, but I'm going to put a graph here so we can see exactly what we're looking at. So I popped in the graph, and as we go from 0 to 3, you can see that the function lies above, the graph lies above the x-axis, so it's positive. Between 3 and 7, the graph lies below the x-axis, so the function is negative. And then again, from 7 all the way to 10, the graph is above the x-axis, so it's positive. So we are trying to find the area bounded by the function. I want the area in here. That yellow doesn't show up real well. I want that area here, and then this area over here. Now, what we can't do is this. I'm going to say it here. Don't do this. Don't just integrate from 0 to 10 of, what do we got here? X squared minus 10x plus 21 dx. So I already computed this out, and here's what I got over here. But this is wrong. This is not the area. I'm going to put something back in here. This is what we had a couple sections ago, or last section, where we're going to relate area and the definite integral. So look at this definite integral here. Here's the conditions that have to be satisfied before you can use it. All right, first of all, you have to have a continuous function. Now, we have a continuous function, right? There's no holes, breaks, or gaps in this function. Continuous function, but it has to be non-negative. This function is not negative from 0 to 10, right? From 0 to 10, it goes positive, then negative, then positive. So here's what we're going to have to do. Here's how we deal with this. We're going to say that the area is going to be, we're going to go from 0 to 3 of f of x dx, and then minus, now, minus, because, why minus? This is negative down here, so if I take negative and negative, I get a positive, so I'm turning that, it's like just taking this and flopping it right up here, of f of x dx from 3 to 7, and then I'm going to add in the positive from 7 to 10 of f of x dx. So let's give this a try. We're going to say now that the area is the integral from 0 to 3 of, what do we have here? X squared minus 10x plus 21 dx minus the integral from 3 to 7 of x squared minus 10x plus 21 dx plus the integral from 7 to 10 of x squared minus 10x plus 21 dx. Now, when we get this integral here, we're going to get, when we integrate this, for all three of these, we're going to get x cubed over 3 minus 10x squared over 2 plus 21x, but we can simplify this. This is going to give us x cubed over 3 minus 5x squared plus 21x, and then we're going to substitute our lower and upper limits into this. So what I'm going to do is right up here, just substitute our numbers in. So remember the first integral here, that goes from 0 to 3. We evaluate it, and then we come up here. I'm going to evaluate that from 0 to 3. Then minus the second one, because this is the one that's below the axis. That's going to go 3 to 7. And then the last one is above the x-axis again, so 7 to 10. Now let's get some more room here. So here it is again. I just rewrote it. So let's do this. So we're going to get 3 cubed over 3 minus 5 times, I'm going to block it off like this. Here's the first one. 5 times 3 squared plus 21 times 3, close, minus, but in the lower limit, 0 cubed over 3 minus 5 times 0 squared plus 21 times 0. There's the first one, plus, no, not plus, minus, right? Minus the second one. Start with the upper limit. 7 cubed over 3 minus 5 times 7 squared plus 21 times 7, okay, parentheses, minus, put in the lower limit, that's the 3, so I'll get 3 cubed over 3 minus 5 times 3 squared plus the 21 times 3, okay, and then plus, here is the very last one, put in the upper limit, all right, so this will be 10 cubed over 3 minus 5 times 10 squared plus 21 times 10 minus, put in the lower limit, which is the 7. So I'll get 7 cubed over 3 minus 5 times 7 squared plus 21 times 7. Okay, we got them all. All right, so some arithmetic here. This first one, all right, so when I do the first one here, I'll write it here. I got 27. See if I keep track of these. Now, this is all 0, right? When you compute with 0, that whole thing just becomes 0. And down here, this one here, when I put in the 7, I computed that to be 49 over 3. 49 over 3 minus this one. Well, look, we just did this one, right? This one I know. That's already a 27. So I'm just going to write 27 in there. That's going to be 27. Now, what about this one down here? This one here. Now, when I did that one, I'm getting 130 over 3. And this one here, okay, that's with the 7s. That's with the 7s, right? And we just did the 7 up here. I know what that one is. That's 49 over 3. So this one here is 49 over 3. Let's put it all together and see where we are. So we have, okay, we've got 27 minus 0 minus, okay, what's that middle one? 49 over 3 minus 27. And then the last one, which is 130 over 3 minus the 49 over 3. Okay, I'm going to remove all these parentheses. So I'll get 27. All right, the 0's gone. I'll write it anyway. Minus 49 over 3 plus 27. Let's get rid of that big line. Plus 27, right? You see the plus 27 minus a minus? Plus 27. And then plus 130 over 3 minus 49 over 3. Now, I've got two of those 27s. I've got two of those negatives, and then I've got this one right here. So when I added all those together, I got 194 over 3. And I did that on Wolfram Alpha. All right, so that's what we're going to claim as the area bounded by that curve.